Here is another set or another system of equations, and we don't want to do this by graphing because you have to solve it for y and then graph the two things, see where they touch, and we don't want to do it by substitution. Do you know why? Well, I'll tell you why. It's because if you were to pick either one of these equations, let's say we pick the second one down here, and solve it for, say we solve it for x. When we solve it for x, we'd have 2x equals 5 minus 3y, and then we'd divide both sides by 2, and then I'd have 5 halves minus 3 halves of y, and then you'd have to take that and substitute it into the other equation. And I don't know about you, but I wouldn't want to do that. That seems kind of messy. So instead, let me get rid of all this. Let's pretend like this never even happened. Instead, what we're going to do is by elimination. By elimination, we're just going to pick one of the variables to get rid of by multiplying the equations by some multiple. Okay, so I can easily get rid of the x here because I can just multiply this bottom equation by -3. When I multiply it by -3, this term will be -6, and when I add it to the first one, those two will disappear. So let me rewrite my two equations. Top one stays the same. I'm not multiplying it times anything. Now, I take this -3 and just distribute it through. So -6x minus 9y equals -15. Now, add your two equations. Just matching up your like terms. These cancel out. There's no more x's. That's why it's called elimination. 5x minus 9x is a -4y, and this is 19 minus 15 is +4. Divide by -4 gives me -1. There's half the answer, and I just pick one of those equations, stick negative in for y, -1, and find out what x is. How about 2x, the second equation, the original one, plus 3 times -1, where I substituted in my -1, equals 5. And now work it out. 2x minus 3, add that 3 over, I'll get 8. So x equals 4. My actual answer is the ordered pair 4, -1. And that'll do that.